Hi all, today we prove theorem 22. In theorem 22, we have to show that, first we have to show that uh, these V and W are vector spaces over field F and T be a linear transformation from V into W. So this T from V into W, and first we prove that the null space of T transpose. So null space of T transpose is same as the annihilator of. That means annihilator of range of T. So that is RT. So we need to prove that NT transpose equal to RT annihilator. So first we write first we understand what is this NT. If we have T transpose is a function from W star to V star. So this is a linear transformation, and the null space of T transpose. So this is that is a subspace of W star. Okay, and we have V is here. This is our V, and this is our W. Then T is from V to W. Then range of T. Range of T is always a this is the range of T. Range of T is always a subspace of W. N T transpose is a subspace of W star, and this range of T is a subspace of W. Then range of T the range of T annihilator, RT annihilator. What is RT annihilator? This consists of all elements of the dual of this W. That means G belongs to set of all G belongs to W star, such that this G sends every element of RT to 0. That means G of any beta equal to 0, beta belongs to range T. So this is the definition of annihilator of R of T, and you can write it as set of all G belongs to W star, such that G of any beta belongs to range of T, that beta takes the form T alpha. So G of T alpha equal to 0 for all alpha belongs to V. So this is the definition of R of T annihilator. And what is N of T transpose? We know that this T transpose is a function from W star to V star. So this consists of set of all G belongs to W star again, such that T transpose of G equal to 0. What do you mean by this equal to 0? That means identically equal to 0. So this consists of set of all G belongs to W star, such that this T transpose G is nothing but G composition T, that is G of T alpha equal to 0 for all alpha belongs to V. Okay, so obviously these two sets are same. Okay, T transpose G identically equal to 0 means G of T of alpha equal to 0, and from these two this is equation number 1, and this is equation number 2. We can from 1 and 2, 1 and 2 implies that range of T annihilator equal to null space of T transpose. The other way you can prove this equality of two sets using the inclusion. If you choose an element alpha from element G from this, then you can get G beta is equal to 0 for beta belongs to R of T. Then consequently G of T of alpha equal to 0. Then that implies that G belongs to null space of T transpose. Consequently, conversely, you can take an arbitrary element of this set. G belongs to W star with this condition, that is G composition T is identically 0. That means G composition T of alpha equal to 0 for all alpha belongs to V, because G composition T is a function from this V to F. So this is 0. Then consequently you can get this G satisfies this condition. Then G should be an element of this. So you can easily get the equality of these two sets. So that's a trivial thing. What we have proved here is true for an arbitrary vector space. Vector spaces V and W. that means this result is true for any vector space irrespective of their dimensions, even whether it is finite dimension or infinite dimension. But if you restrict our vector spaces to finite dimension with dimension of v is equal to n and dimension of w is equal to m, then you can get the other two statements in the theorem 12, that is rank t transpose. Rank t transpose is same as rank t, rank T, and range of T transpose is annihilator of the null space of T. Okay, so we can easily prove these two statements. So first we prove the first statement, rank T transpose equal to rank T. So rank T transpose is defined as a dimension of range of T transpose, and range of T transpose is denoted by this symbol, range of T transpose. Then we need to prove that this is same as dimension of range of T. So first you assume the dimension of range of T, or rank T, is equal to some R. Then we have, if W is a subspace, then dimension of W, or if we have any subspace W, or some S is a subspace of V, we have dimension of S plus dimension of S annihilator is dimension of V. So this is the case when we have a subspace of V. So if you apply this for the subspace T, rank of range of T transpose or range of T, you can get this range of T is always a subspace of W. Then you can say that dimension of range of T plus dimension of range of T annihilator is dimension of W. So that is equal to M. So we start this result. We have a dimension of range of T annihilator is M minus R. So this is the immediate consequence of this dimension of V and dimension of W. Now we know that this dimension of we can apply the rank nullity theorem here. Then dimension of rank T transpose, that is dimension of range of T transpose plus nullity of that means the dimension of null space of T transpose, that will give the dimension of the domain of the T transpose. The dimension of the domain of T transpose is same as dimension of W star, that is same as dimension of W, that is equal to M. Okay, so from this you can write dimension of the range of T transpose plus the dimension of null space of T transpose. We have already seen that in any case null space of T transpose is same as the annihilator of range of T. So this is same as dimension of the range of T annihilator, that is equal to dimension of W star, that is equal to dimension of W, that is equal to M. But from this you can write the dimension of the range of T transpose is equal to M minus, this can be written as dimension of null space. This value is M minus R, so we can substitute this dimension of range of T annihilator as M minus R, so that is equal to M minus R, that will give R. What is R? R is the dimension of range of T. So this gives a rank of T transpose the same as a rank of T. So this is true for finite dimensional vector spaces. Next we will show that the second result, the range of T transpose is same as the null space of annihilator of the null space of T. So that is null space of T annihilator. So we will prove this result by proving that this range of range T transpose, this range T transpose is contained in null space of T annihilator, and these two subspaces have the same dimension. That is range T transpose and the null space annihilator of this null space of T has the same dimension. Okay, so we'll prove this inclusion, and we'll prove the dimensions are same. Then you can easily get this result. Okay, so we'll prove this. First we choose this range of T transpose. This T transpose is a function from linear transformation from W star to V star. Then this range of T transpose is a subspace of V star. So I choose F belongs to this range of T transpose. Okay, so that implies what is the meaning of this? This F can be written as some T transpose of G for some G belongs to W star. So this implies we will prove that this F is a member of annihilator. That means if we choose any alpha belongs to how will you prove an element is an element of annihilator? That means that annihilate every element of this NT. So we choose alpha from the null space of T. We know that this implies T alpha is always 0. So that implies this G composition T alpha is equal to 0. That implies this is G composition T of alpha equal to 0. That implies T transpose G of alpha equal to or you can interpret it as that is T transpose G equal to 0 for all alpha belongs to the null space of T, and consequently we can get this T transpose of G is nothing but F of alpha equal to 0. This is of alpha. F of alpha equal to 0 for all alpha belongs to NT. This means this alpha belongs to NT implies F alpha equal to 0 for all alpha belongs to NT. That means this F is a member of NT annihilator of the null space. So this implies that F belongs to range of T transpose implies F belongs to null space annihilator of null space of T. So consequently we have this inclusion, and next we will prove this range of T transpose is same as the dimension of the range of T transpose is same as dimension of the annihilator of the null space of T. So that is because we know that this dimension of null space of T annihilator is same as the n minus the dimension of null space of T. Okay, because the dimension of null annihilator of null space of T plus dimension of null space of T will give n, the dimension of V. Okay, these are subspaces of the V. This NT is a subspace of V. Then we can write this one n minus dimension of null space of T. That means n minus nullity is the rank T. That means dimension of range of T. Dimension of range of T. So that is same as we know that range T is same as range T transpose. We have already proved in the first case. So this is same as the dimension of range of T transpose. Consequently, that is dimension of or this is the required dimension of null annihilator of null space of T transpose, same as the dimension of range of T transpose. So this would imply that we can say that this is also true now. That implies from these two statements you can get range of T transpose is same as the annihilator of the null space of T.